Hello everyone, this is Travis Tidwell, and I'm going to be giving a revised edition of my JavaScript Essentials video. As a quick introduction, my name is Travis Tidwell. I am the CTO and co-founder of a new company called Form.io. You can also find me on Twitter under the handle Software Gnome, so go and follow me, that'd be awesome. And another place that you can find me is on GitHub, where I submit all of my code repositories as well as all of my open source contributions, in addition to this presentation that you can actually find all of the source code available to you at github.com/TravisT. Before I do begin, I would like to give a quick introduction to the software company that I'm involved in called Form.io. This company is a product that provides developers this very easy drag and drop interface that allows them to create not only the forms, but also the APIs in one step. And those forms can easily be embedded into your application using an HTML tag that works very similar to an image tag. If this sounds like something that interests you, please head on over to Form.io. We'd like to hear from you and see what you think. Another thing that I like to do is I like to offer presentation materials for anyone going through this presentation. If they'd like to see this within their own browsers, you can easily do that by going to the following URL, which is bit.ly, and it's 1QBMC1U. And what you'll see there is it goes to my Travis Tidwell website under my presentations, and this presentation will show up. So before I begin, I'd like to talk a little bit about who is this presentation for. This presentation is for developers who already know how to write software, but they just want to learn how to program in JavaScript. So one thing I'm not going to be doing in this presentation is teaching you how to write software. I'm really making the assumption that you already have some experience with that. Maybe you program in another language called C++ or maybe PHP, and you've heard about this thing called JavaScript, you're very interested, and you just want to know all the things there is to know about it coming from a person who already knows how to write software and how to be an effective JavaScript programmer. Another thing that this presentation is for the JavaScript gurus out there who are just looking for a few nuggets. I know myself, I really appreciate watching presentations and learning a few things that I didn't know before. And I feel like there's a big possibility for someone who already knows JavaScript to find these little nuggets within this video. Another thing I'd like to talk about is what will we learn. So we're going to learn all of the must-know items to be a JavaScript developer, and more specifically an effective JavaScript developer. Now there's a lot of videos out there that teach JavaScript theory, some of the underlying mechanics of JavaScript. One thing you'll learn, the deeper you get with JavaScript, it just seems to get deeper and deeper and deeper, and you don't really get to know everything. However, there are a few things that you need to know to really become an effective JavaScript professional developer. And those are the items I'm going to be covering in this presentation. There's also a lot of gotchas with JavaScript, things that throw you off, and a lot of people fall into pitfalls that they read on some tutorial that tells them to do it a certain way, but that actually has problems associated with it. JavaScript is riddled with these type of things, and so I'd like to cover all of the common gotchas with this as well. And also there's a lot of accepted development patterns with JavaScript. One thing that you'll learn is that because JavaScript is extremely flexible as a language, it also opens the door wide open for people to not incorporate the appropriate patterns. And if you don't do that, sometimes JavaScript will punish you. So I want to make sure that I cover all of those appropriate patterns. And last, I'd like to say, why should we learn this? Why would you want to learn about JavaScript, and why would you spend the time? And I think it can easily be stated, and I don't know many people that would challenge this statement, but JavaScript is rapidly becoming the ubiquitous language for the web. It's everywhere. It's not only on the front end now, but it's also on the back end with Node.js. And there's a number of libraries that expose JavaScript to a multitude of devices. For example, Apache Cordova, you can compile a JavaScript application for mobile phones, which is an exciting new technology that uses JavaScript to essentially deploy your app anywhere. So it's a very exciting technology, and I think everyone should learn it. So just really quick, let's go over the agenda that we're going to be going over today. We're going to first start off by talking briefly about the syntax of JavaScript. Next, we're going to be talking through some of the patterns, common JavaScript patterns associated with the language. We're going to go into objects, functions, which are a very peculiar item within JavaScript that are also extremely powerful, so I'll be going into that. There's also a lot of controversy around the this pointer within JavaScript that causes a lot of confusion, especially for people who are used to the this pointer in different languages. One thing you'll find out is that the this pointer just does not behave the same, and it is really confusing for people who are very new to the language. So we're going to spend some time talking about that as well. We're then going to get into some object-oriented JavaScript, and then finally, if we have enough time, we're going to get into some applications of JavaScript in the form of jQuery plugins. Alright, so now what I'd like to do is I'd like to talk a little bit about the syntax of JavaScript. And instead of doing everything within this presentation, it's probably going to be a little bit better if I jump over to my IDE, where I can essentially program and show you some examples of syntax of JavaScript. The first thing to note is that JavaScript is a dynamically typed language. And what that means is I can use a single keyword called var to create a variable and assign that variable to any type. So I can assign it a string, I can assign it a number, an object, an array, and then even more importantly, I can assign that object of any type to another variable of any type. JavaScript is very flexible about what you do with variables. So just as an example, I'm going to use the var keyword to define a variable. I'm going to call the variable testString, and I'm going to assign a string to that value. So I'll just say Travis. Now what I've done here is I've created a string and I've assigned it to a variable called testString. And the var keyword is just quite simply to tell JavaScript that this is a variable. I can also create another one called testNumber. And I'm going to give it a numeric value. And so essentially what I'm doing is using the same method to create variables of any type. What's crazy about JavaScript is because it's so dynamically typed, I can do something like this where I reassign the variable to a different type, and JavaScript is perfectly okay with this. It's completely legal to do that. Where you start getting into trouble with dynamically typed languages is whenever JavaScript does something called inference. And what it does is it infers the type of a variable based on how that variable is used. Let me give you an example. So right here what I'm going to do is I'm going to take a string, but I'm going to assign the string a numeric value of 42. So here I have a string where the string's contents is 42. And what I'm going to do is I'm actually going to subtract an integer from that string. Now, in most languages, it just flat out will not compile if you do something like this. But JavaScript is very happy to comply. What it does is it infers that this string is a number. And whenever it infers that, it actually converts this string 42 to the numeric 42 and then subtracts the 2 from it. So what you get if I run this is you actually get a numeric value of 40. So JavaScript inferred that 42 is a number. Where you get into trouble is if I did something like this where I just quite simply reverse the logic, and instead of subtracting 2, I am going to add 2. Now based on the previous example, you would think that this would give you 44, but what it does in fact is give you 422. So now this is an example of where JavaScript behaves in such a way that really frustrates developers because JavaScript infers the type of variables at runtime. In this particular example, what it's actually doing is it recognizes the plus symbol as being a common operation for concatenation of strings. And because it knows that, it says, okay, here's a plus and it's right next to a string, therefore 2 must be a string. And it actually then infers that 2 is a string and concatenates it to 42. And what you get is a string 422. That's exactly what is happening here, but as an illustration, this is something that causes a lot of problems in JavaScript. One way to get around this is to be explicit about your types in JavaScript. And what I mean by that is anytime that you have a variable, so let's say that this was actually a variable called the meaning of life, and I'm going to assign it a string called 42. And instead of that, I'm going to replace this inside the console log. I'm going to hit run, and you should get the same thing. However, if I use a single command called parseInt, this is basically telling JavaScript to parse whatever is inside this variable as an integer before you perform the operation. This is one way to get around this type of issue, because you're basically telling JavaScript, I want to convert this to a number before you even do anything else. And so then you get what you expect out of it. Another thing that is very common in JavaScript is to use a keyword called type of. And type of, what it does is it essentially interprets the type of a variable. So if I were to do type of, I'll do a console log here, so console log type of Travis, what you will actually get is you will get string. Let's do console log type of 42. You will get number. So this is a really good way to, in runtime, to try and determine the type of a variable. So these could actually be assigned to a variable, and you can say type of on that variable, and you would get the same thing. You do run into an issue with type of, and a lot of times people will use type of to try and find the types of instances of objects. So just to give you an example, if I say person, and I say first name, last name, and we're going to go over objects here in a little bit. And then if I did console log type of person, what you would get is you would get what you expect. You get an object. But what if we made this an array of persons? So all I'm doing here is I'm calling it persons, I'm making an array, and inside it has a single person with that, and then I say persons. Most developers would expect this to return a type array, but let's actually see what happens here. It actually gives me object. Why is that? And this is where type of can get you into trouble. The reason why is because type of, you're actually doing a type of an instance of a variable, of an array. So you're saying type of the instance is an object, and this is something that'll commonly get people. And just keep in mind, if you use type of, don't do it for instances. Do it for primitives. Is when you would want to use type of. To get around the instance issue, there's another keyword, and that keyword is called instance of. And so if I were to say persons instance of array, this would actually return true, because it knows that persons is an instance of an array. So to get around the issue of having type of in instances, use type of for primitives, use instance of for instance variables. So that's a very good nugget for people who are trying to dynamically determine the types of variables. Another thing to mention about JavaScript is that everything is an object, even primitives. And what this means is that I can actually take a string like this and use it as an object. And an object can have properties. And for string, one of those objects is length. So I can determine the length of a string by just doing a period right after the string and saying length. The reason why I can do this is because the string primitive is an object. And on an object, I can get to its properties using the period sign. This also works for functions, which will blow your mind whenever we get to that point in the presentation. So another thing to keep in mind with JavaScript is everything is an object, even primitives. Let's move on. So the next thing I'd like to talk about is using patterns within JavaScript. And the reason why I want to focus on this is because JavaScript is so flexible that it gives the developers many different ways to solve a single problem. And while this is very good from a flexibility standpoint, it's somewhat of a negative if you as the developer do things in a certain way that are not typical convention for what other developers are doing. And it makes your code hard to read from other developers, but it also, if you do things in a certain way, causes problems within your software. So there are a bunch of references online with patterns within JavaScript. These URLs are ones that I highly recommend that you visit and read up on. I'm only going to give you an example of some patterns in JavaScript. The easiest one to talk about is creating objects. So I can actually create an object pretty easily in JavaScript by creating what's called a new object. And because I created a new object, I have access to create properties on that object. So I'm going to say first name, Travis, person, last name, Tidwell. And then I'm just going to do a console log of that object. And you'll notice that this is perfectly fine. And in most cases, this is fine. You run into an issue, however, because with new object, if you use that same convention with other types, there's a problem here. So just to give you an example, I'm going to create a new object, which is going to be an array. And inside the array, I'm going to add multiple entries. So 22 and 24, and then I'm just going to do a console log of that array, and you'll notice that here I have an array that has two values in it. One is 23, one is 24. But what happens if I just remove one number here? And so essentially saying, okay, now I want to create an ages array that has just 23 in it. If I were to do a debugging that, instead of getting what I expect, I get an array with 23 empty entries, which is something that is very difficult to understand from a developer and actually presents what's called an anti-pattern. And so using arrays in this way, or even creating arrays in this way, is not considered best practice. What is considered best practice, and this even applies to objects, is to use what's called JSON format. So if I were to create a new object, it's the same thing as saying open squiggly bracket, close squiggly bracket, and in here I provide my properties. Now this is essentially doing the same thing as new object. In fact, it's very important to understand as a developer that whenever I declare an object this way, it really is using a new keyword in the background, and it's creating a new object and assigning the properties as first name and last name. The reason why I like this, in fact I can just do a console log just to show you, all is well. The reason why I like this is because it applies to pretty much any other type within JavaScript, including arrays. So I can now create 23, 24, and let me just do a console log of the ages, and you'll notice that all is well, but let's try out the problem last time just to see if it is a problem, and it's not. So the best pattern for creating objects and creating arrays is to use this JSON format. Now, keep in mind, that was just a very small example of common patterns within JavaScript. I could spend an entire hour alone just talking about patterns. So what I'd like to do instead is direct you to these URLs where you can learn all about patterns, and I highly recommend doing that. So let's move on. Let me delete this and move on to the next section. So the next thing that we're going to talk about is we're going to talk about objects within JavaScript. And objects are very, very important because pretty much everything within JavaScript is an object. And to define it easily, an object is an unordered collection of key value pairs. Now we got an early on taste of what an object is within this tutorial, but I'd like to do a little bit of more of a deep dive into some of the mechanics behind it. So to create a new object, you simply use the var keyword, you assign a variable, and then you use the squiggly brackets to define a new object. And within those squiggly brackets, you can then define properties for the object using the property name, and then using a colon and then the value for the property. So here I'm actually saying this is the key and here's the value. One thing I will note is that the key is a string, so it's actually valid to denote it as a string. So I could do something like this if I wanted to. However, proper convention says to leave out the quotes because it's more object-like, and it is also a little bit easier to use whenever you're declaring those properties within dot notation. Speaking of dot notation, once I create an object, the way that you get to this property is to use something called dot notation. And the way that works, so let me just do a console log real quick, is I can type the name of the variable, which is the object, and then I use a period. The period is dot notation, and it basically says I want to access a property within this object. So then if I just type first name and run this, what you'll see is it actually prints out what I expect, which is the value of first name. Now I can also add other properties to this person, such as last name, and even then when I run this, it's only going to be accessing the property first name because that's what I explicitly provided within here. However, I could create a first name last name by appending a space and then doing last name. And then when I run that, you'll see that because I have access to both properties, I can pick and choose how I want to format it using string concatenation if that applies to the properties. Another thing to note is that the values within an object can be anything. And what I mean by that is right now we're using strings, but these could easily be functions. So like if I said, created a method called getName, I could actually provide a function, and that function can be the value of the key called getName, and I can access it this way. So if I were to say return this first name, this last name, and we will go over this pointer here pretty soon, I now have access to that function, and it essentially does the same thing, but I'm essentially accessing the getName method within the person object. So here we have a key and the value is a function. Another thing that you will commonly see is the value is another object. So in this case, let me do an address property. So here's the key is called address, and I'm going to create a value which is another new object. So here I'm just going to say zip street. And so now at this point, I have an object within an object. So how would I access, let's say, street, for example? Well, using dot notation, you can actually use dots iteratively or recursively is probably a better term for it. So here I'm going to say person dot address. This gives me access to this address value, and within this address value is a property called street. So to get to that, I add another period and I say street. So here I'm basically accessing these sub properties within objects very easily doing this method. So let me just run that real quick, and you'll see that this now prints out the street name. So some very powerful concepts here, all revolving around this very flexible thing called an object. So the takeaway here is it's a key value pairs. The key is a string but can be typed without the quotes, and the values can be anything within JavaScript. It can be primitives, it can be other instances of objects, it can be anything. So let's move on. Actually, let me delete this before we do. So let's move on. Alright, so let's talk a little bit about functions in JavaScript. Now I find functions very fascinating, primarily because they are critical to how JavaScript works, and they are very different and behave different than a lot of other languages that you may be familiar with. One of the very first things that people notice whenever they're dealing with functions is that functions can be used as functions, but they can also be used as objects, which kind of blows people's minds a little bit. And what I mean by that is I could actually create a variable called my function, and I can assign it a function. So now this means that the variable function is a function, and so then whenever I call this, I could do something like log. But now that I have this function, I can also do some other pretty crazy things, like I can assign a property to it. And this is perfectly valid. In fact, if I did a console log of this, just to kind of see what this actually did, you'll notice that this is perfectly legal. In fact, it says that this is a function, and it shows that I have a property called Travis on here. And another thing that you'll notice is that I actually have a fully working object instance, which is my function. Now, I know what you're probably thinking next, which is why would you ever want to do this? What is the use case where you would have a function and then assign a property to that function? Well, as it turns out, this is used a lot within object-oriented JavaScript, where let's say I have a person and that person is my object, and then let's say within the person I create a property called first name. This is all perfectly fine. You see this a lot. Where you see the properties being defined is whenever you're using something like a static method. So let's say I want to do person find one. You find this a lot like within NoSQL databases, and this is a function that you want to iterate and find a person and then create a new instance of that person and return it. This is a very common example of why you would want to use properties within a function. All right, so the next thing that I'd like to talk about is that functions can be anonymous. And what that really means is, in fact, you see this a lot whenever you're dealing with set timeout is a great example. And the way that set timeout works is it's a JavaScript command that tells you to execute a function after a certain delay has occurred. And that function can be declared as anonymous. In fact, more times than not, you see set timeout take an anonymous function. And so you'll notice here what I'm actually doing is I'm not giving this function a name. All I'm saying is this is a function and I'm passing it to set timeout. So inside of that function I could do something like hello there, and then if I execute this you'll notice that it waits 1 second, and then after 1 second it says hello there, which is to be expected. The point I'm trying to make though is that I actually created a function without giving it a name. This is an anonymous function. Another thing that you can do is functions can be self-executing, and what that means is you actually declare a function. So to declare a function you do something like this, and then you call it immediately. But in order to call it immediately you must first wrap it in parentheses, and then once you wrap it in parentheses you can actually execute that function immediately. Now a lot of you have probably seen this syntax, and it's very confusing when you look at it because it's quite ugly. You have a bunch of parentheses, you have a bunch of brackets, and it technically doesn't look like it's doing anything whenever you see this. But it is in fact doing something, and it serves a very important feature in JavaScript, which is this idea of encapsulation. To illustrate that, let's actually change our code a little bit. So instead of doing set timeout here, hello there, what I'm going to do is create a message variable called message. And I'm going to assign that message to that, and then I'm going to put that inside of here. And for now I'm actually going to delete my self-executing anonymous. I'm going to run it. Everything should be fine. Yes, it is. Now let's suppose that this code was inside of a JavaScript file called app.js. And you're including this within your web page, but also in your web page you're including a vendor.js file, a file that you have no power over. This is something you downloaded. You don't want to change it. But somewhere inside of there, it is actually looking for a message variable. So like if it says if message, and then it does something really bad. So like in this case, I'm just going to say, barf or something, right? It is not happy if it sees that there's a message to find. If you were to do something like that, and if you were to run it, you'll notice that the other vendor library is not going to be happy. In fact, sometimes your entire website will crash because of this. I'd like to explain why this is happening, and the reason why this is happening is because in this instance, we are creating a variable on what is called a global scope. Now I'm going to talk about scopes later on in this presentation, but for now all you need to know is that whenever I declare a variable, that variable is accessible from even other JavaScript libraries that also include variables on the same scope. So in this case, this message is being passed to vendor, or it's actually being added to a scope. That scope is also common with the vendor.js. So how do you fix this problem? Well, you fix this problem by incorporating the self-executing anonymous functions. So let's actually go back up here to the app.js, and what I'm going to do is I'm going to create a self-executing anonymous function by first creating the function. You then have to wrap that function in parentheses, and you have to wrap it in parentheses so that you can call it immediately. This right here is the self-executing anonymous function. At that point, I can copy this logic, place it inside of there, and what I essentially have at this point is contained logic within its own scope, and I think that's the key word here. Whenever you create a self-executing anonymous function, what you are doing is you are establishing an encapsulated scope for your logic. So, and actually this will actually error out because this message isn't even defined, which I can even show you right at that point. You see message is not defined, that is expected, but the point is that this logic will work. So I could actually fix this by just saying type of is not equal defined, and then if I run that again, you'll notice everything works just fine. Message is not defined, so therefore it doesn't barf, and everything and everyone is happy. Now again, what I've essentially done here is established context, which actually brings me to my next discussion, which is that functions encapsulate and capture scope. Now scope is a very important word for functions, and in order to help illustrate how scope works, what I'd like to do is refactor this code just a little bit by first turning this into an array of messages. So I'm going to say messages. I'm going to make that an array, hello, there. And then what I'm going to do is iterate over the messages by just using a simple for loop. I'm creating a variable which will be the index inside of the messages. And then here what I'm going to do is just do a console log messages and I'm going to remove my little set timeout just to see if I have at least a logic that I expect, which it is. I see hello and then there. This all works great, but what would happen if I put this console log within something that's asynchronous? And the best way to simulate that is to use set timeout. So I'm going to do set timeout. I'm going to pass it an anonymous function, and then I'm just going to put a delay on there for, like, let's say 10 milliseconds. And then I'm going to copy my console log and I'm going to put it inside of that set timeout function. Now what most people would expect to happen in this situation is they would expect it to still say hello there. They would just be delayed from each other, 10 milliseconds away from each other. What really happens though, in fact, is something that baffles a lot of people. So if I run this, what you end up getting is it prints out there twice. It doesn't say hello there. It actually prints out the last one, but it prints it out twice. Immediately what most people think is they're like, oh well, it's just it's happening too much delay. What if I made that like 1 millisecond, as low as it possibly gets, and if I hit rerun, you'll notice it still does the same thing. So what is actually going on here? Well, what is happening is that we are defining this variable I within a certain scope, and that I is established within the scope of the for function. So anytime inside of this function, anytime you reference the variable I, it's actually referencing the one that's defined right here. Well, what happens is in set timeout, it actually executes this function in a delay. And so by the time that delay is finished, I is already the very last index in messages. So instead of printing hello, which is index 0, and then there, which is index 1, by the time this function gets executed, I is already 1. So in that case, it calls console log 11, and you get something that's very, very unexpected. This typically will make developers throw their computers out the window whenever they're dealing with JavaScript. This is one of the more common gotchas that gets developers. And the reason why it gets them is because of this whole concept around function scope. So in order to really illustrate function scope and how we can fix this, I'm actually going to do something that seems a little less intuitive than you would think on something that could fix it. Let's actually say that we create a new function up here, and I'm just going to call it say, and this function takes that index. And all I'm going to do inside of this function is quite literally copy and paste this set timeout method inside of the for loop, and I'm going to paste it inside of that function. And then all I'm going to do is copy this method, and I'm going to do say I. Now, most people, whenever they're dealing with functions, they have this notion that whenever you create a function and you essentially copy and paste the same logic, it does the same thing. However, in this particular case, this fixes the problem. Hello there. Now, I know what a lot of you are thinking, like, how in the world does that fix this problem? The reason why it fixes it is because whenever we call say and we pass in the variable I, this I is handed to this function and establishes a new scope for this variable. So it's almost identical to us creating a new variable within this function scope and assigning it there, so that by the time that this set timeout is called and executed, this I is no longer referring to the for loop I. It's referring to the I that was passed into the say function. An easier way to really illustrate this is to just give this a different variable name. So we'll call it index. And then instead of I, we'll just say index right here. This illustrates it a little bit better because now we're creating a new variable name. And that variable essentially captures the context of I at the point it's executed. So in that case, it actually works. So this is a very powerful concept inside of JavaScript, and it's this whole concept of scope and encapsulating and capturing scope within functions. Another thing that's very common is this idea of what's called a closure. Now, we haven't actually created a closure yet. A closure, in order for it to be a closure, you have to actually have a function, which I guess in this case it is a closure because we actually have a function that references a variable outside of the function. A very common syntax for a closure, though, is let's say that we want this set timeout to be outside of the say function and inside of this for loop. So what you would end up doing is you would say set timeout, and after, let's say, 1 second, you want to say whatever is inside of the messages at I. So in order to get it to work in this context, instead of saying set timeout here, all we need to really do is return that function. And then when we return that function, we can get rid of this. We are essentially passing this function to set timeout to be called after 1 second. So let me actually just run that and see what happens there. It says hello there, all after 1 second. Everything works as expected. What I've done here, though, is I've created a very common pattern for a closure. A closure consists of a wrapping function that takes an argument, and that argument captures the context of that. And then inside of that, we return essentially another function whose sole purpose is to be called at a later time, but when it's called, it utilizes the variable at the point in which the closure was instantiated. So this is a very common pattern for closures in JavaScript. It also segues very nicely into the next section, which is called the module pattern. Now, modules in JavaScript are a way to create these encapsulated, reusable plugins within JavaScript. And we've essentially done a lot of the stuff that you need to create a module. But right now, essentially what I'm going to do is just kind of go over all of the syntaxes. Another thing that modules are really good for is they allow you to create public and private interfaces within your module. So let's just take this example as a use case, but let's say we want to create an alert module that gives somebody the ability to add new messages and to print the messages. So essentially what we can do is we can keep this messages array as it is, although instead of defaulting messages to be in there, we're just going to make it an empty array. And then essentially I'm going to delete all of this logic for now. So then what I'd like to do is I would like to be able to create a module or a class called alert, and it basically gets the public interface of this message. So here I'm doing a self-executing anonymous function, but inside of here I'm not returning anything. So if I were to execute this, alert would be nothing because it's assigned to whatever is returned from this anonymously executing function. Nothing's being returned, so it's not going to be anything. However, I can return something here. In fact, I will. So I'm going to say return an object. And this object is the public interface for alert. So here I could actually say add, so which allows you to add a new message. And I could say log. And for right now, all that log is going to do is console log the messages. Now, what's really cool about this is I now have a private variable that cannot be accessed outside of this closure, the anonymous closing, or the self-executing anonymous function. And all I really have access to are the public interfaces that I return from this. And this is actually what's called a module pattern. And so to actually use this, let me actually create, so messages, push, message. So let me actually just use this and see what this looks like. So let me actually do a console log alert. And there you'll see I have only the add and log functions available. You'll notice I have no access to messages, but I can add a message by saying alert, add. I can do alert, add there. And then I could actually do a console log, or I can just call alert log, which will do a console log of all the alerts. So here is a great way to see that with the module pattern, I can create a public and private interface for a reusable module. It's a very, very powerful concept here, and it's very commonly used for when you're creating plugins that need to be shared by other people. This also segues very well into what is also called the CommonJS module pattern. And CommonJS is used primarily within Node.js. So if you're doing a lot of Node.js development, you will see this, where essentially what you're doing is you're assigning the class interface to a variable called module exports, and then using that within an external file. And to do this, we really don't need the anonymous self-executing method anymore. So we can actually say, get rid of that, and we can get rid of that. And then instead of saying var alert, we're going to say module exports. So this is the CommonJS module pattern. And the way that this works is you get to include this module from another file. So let's just say inside of our index.js, and we want to say var myAlert require alert in such a way, and this will actually be, let's say this is the alert.js file. But there's one other thing that's missing, and you'll notice that instead of us doing a self-executing function here, we are assigning myAlert to this function. We actually want to assign it to the object that's returned. So really, to get this to work the way we want it to, is we actually have to call that function as if it's the self-executing anonymous function. What that then does is that calls this function and it returns an object. This object is then returned and assigned to myAlert. Also, a very common thing that you see is you see people provide options for their plugins, and they do so within as a variable within the first function. And these options can then be used within the module to provide additional functionality. For example, let's say instead of printing the array messages, we want to join those messages based off of a separator that you provide. And so then what this is going to do is it's going to print out those messages. And so then I actually have the ability now to provide arguments to say I want to show hello there separated by a space, or I could say separated by a comma. The point is that whoever is including my module has the ability to configure it, and they only get access to the public interface, and all of the private methods, private variables, all of that get contained within the module that is going to be exported using module exports. So this pattern is called the CommonJS module pattern, and you see this a lot within Node.js modules. So that's that. Let me actually delete this, and then we will move on. Okay, so now before we get into object-oriented program, what I'd like to do is spend a lot of time covering a very complicated feature in JavaScript, which really revolves around the this pointer. This is one of those things in JavaScript that can be very frustrating, especially coming from a background in C++ or some of these more compile time languages, where the this pointer is very deterministic and it's always essentially consistent no matter how you use it. In JavaScript, that really is not the case. And for those who don't really understand the underlying mechanics of what sets the this pointer, can be somewhat of a frustration for those who are just getting to know how it works. I think in order to really begin talking about this, it's important to describe the difference between scope and context. And this is something in JavaScript that is absolutely critical. And in fact, a lot of people get it wrong. Being very critical of myself, I have a previous video on JavaScript Essentials where I in fact got this wrong. So it's a very common thing to happen. But what I know is critical is that it's very important to understand the difference, so that whenever you talk about context, you always refer to it in a consistent way, and that helps you understand it. So scope is actually pretty easy. We've actually been dealing with scope up until this point. Scope is defined by functions. So anytime you create a new functions within that squiggly brackets of the function declaration is a new definition of scope. And this helps you encapsulate variables. You can use this for solving the asynchronous issues that we saw earlier, where you can capture the value of a variable using the function scope, so that whenever that logic is executed at a later time, that value is consistent. That's pretty easy. When it comes to context, though, this is where it gets a little bit more complicated, because context always refers to a new object, and it's always interchangeable with the word this. So anytime I say the this pointer, I also mean context. One of the general rules of thumbs is that new objects create context, and I use the new word here because new is extremely important in this case. New creates an object. So as just an example, I can create a person as a new object. And when I do that, the person has a this pointer at that point. So I can actually reference the this pointer on that person. However, a lot of you already know that this is not the appropriate syntax. Let's use JSON format. So a lot of times what you'll see is something that looks like this. And you'll see an object that is created, and a lot of times within this object, it will refer to itself as the this pointer. Because this is an object, keep in mind this is the same thing as saying new object. Because we did that, person will have a this pointer, and you can reference the this pointer within the actual object itself. So let's say I have a get name here, and inside the get name I just want to return this first name and this last name. So here I'm essentially, because I'm a new object, I'm a new object because I was created with the squiggly brackets, I now have access to my this pointer, and I can reference my own properties using this. That's a very important concept to understand about scope and context. Where it gets really complicated is how this is assigned, and a lot of people, I think this is the one sentence that a lot of people get wrong. You'll hear very common people say that this pointer is assigned to the object that owns a method. So in this case, I have a method called getName. Person owns that method, so therefore the this pointer inside getName actually points to person. This can actually get you, and it gets you, and it really shows itself. For example, like if I were to do console log person getName, and if I were to run this, I have to actually call it. You'll see that works just fine. Where this will get you into trouble, in fact, let me actually just change the way that this works, just so that to easier illustrate. I'm going to say name, and I'm actually going to put the console log inside of the function. So I'm going to say console log say name. I'm going to change this to say name. And in this case, I don't need console log. And if I run this, you'll see that it says that it does the same thing. What would happen if I put this inside of a set timeout? So I wanted to say name after 1 second. This is where people start getting into trouble when it comes to the this pointer. And how they get into trouble is that they expect the this pointer to point to person whenever this method gets called, because hey, guess what? Person owns the say name method. Well, if I run this is where people get really frustrated. Now I see undefined, undefined. And the reason why I see that is because whenever this method is called, the this pointer doesn't point to person anymore. It actually points to whatever is inside of set timeout. And the reason is because of this one sentence. And this is really important to understand. The this pointer is assigned to the object instance that invokes a method. So in this particular case, let's say person say name, and if I just run this by itself, this works. And the reason why it works is because person is the one that invokes the say name method. Because person invokes say name's this pointer is assigned to that person. In this particular case, the one that actually caused problems, we are actually passing the method say name to set timeout, and person isn't invoking it. Set timeout is the one that invokes it after 1 second. And because of that, the this pointer is all messed up. And so that's one thing. This is another area where developers who are first learning JavaScript, they get really frustrated, they throw their computers out the window, and they just completely bail on JavaScript. And the reason why that happens is because things like this will get you, and you have to understand what is going on in order to really recover from it. In order to recover from it, the next topic is a very important keyword that I use a lot within my JavaScript, which is you can bind context to any method using this keyword called bind. And the way that this works is, let's say I want to do this. I want person say name to be executed after a second. However, I know that whenever it gets executed, that the this pointer is going to be messed up. So what I want to do is I want to force the this pointer to be person when it's executed, so that this points to person. The way I do that is I call bind. If I say bind, I am saying, okay, whenever say name is executed, make sure that this pointer equals person. And so bind takes one argument, and that argument is what you want the this pointer to be whenever that method is executed. So now if I were to run this, you'll notice that everything is perfectly fine. The this pointer is established, the this pointer points to person, and so therefore all is well. So bind is extremely important. Another place that you see this show up is whenever you're actually dealing with classes and instances of classes. So to give you an example, I'm going to create a new class called person. And inside this class, I'm just going to create a property called first name. And then I'm just going to do a really quick console log this first name. And I'm just going to comment this guy out right now so that we don't clutter up our console log. So then you'll see what this actually does. It doesn't do anything because I didn't actually create an instance. Let me create an instance. So whenever I actually create a new instance, you'll see that that property then does a console log. Almost similar to what we did before, what I'm going to do is another set timeout. And keep in mind, whenever I do these set timeouts, really all I'm trying to do is illustrate asynchronous behavior. This could be anything from a GET request. It could be any library that you're using that does something asynchronously. So it doesn't have to be console log here. So what I'm going to do is copy this. I'm going to paste it in there. I'm going to do run again, and you'll notice that it's undefined. Same thing here. What's happening is that whenever this is getting called, the object that the object that invokes the method is not person. It's not the instance of person. So to fix this, we can just use bind, which also illustrates using bind on an anonymous function. I do this a lot as well. You can create an anonymous function, attach bind to it, and then that way you are guaranteeing that whenever this function is called, this pointer will be established. So if I were to rerun that again, you'll note all is well, all is happy. So that's something that you see quite often. And it's also a very important concept, which is binding your context with a bind keyword. Another thing that you see quite often is you can call a method with context using this call or apply. And to really illustrate this, let me just take this method right here called sayName. And what I want to do is I want to make this outside of the object. So I just want to create a var method. I'm going to call it sayName, and it's going to essentially be the exact same thing. And let's just do, so then actually what, let's actually just run this and see what this does. So if I did a console log sayName, actually I don't have to do console log because sayName does do console log. So if I were to execute this right now, what this will do, and I think this is to be expected, is it would say undefined, undefined, and the reason is because now sayName is outside of the person. The object that invokes sayName is not person. It's nothing. It's the global object. And this is first name is undefined on the global object. So to fix this, I need to be able to establish the this pointer whenever I call sayName. And to do that, you use the keyword called call. So let's just say call, and then there what I'm saying is when you call this method, use person as the this pointer. And so that's another way to do it. It's similar to bind, but it's also a lot different. Where you're essentially you are invoking the method versus you're not binding it so that it is invoked later. You are invoking the method with that this pointer. So if I hit run, you'll notice everything is fine because I'm invoking it with the this pointer pointing to person. Another thing that you see often is this keyword called apply. Apply is very similar to call. The only difference is it actually takes the arguments that are typically within an array and it translates them. The best way to do this is for me to give you an example. So let's just say that I want to make my sayName a little bit more flexible, and I can say it in any order by defining the props. So property 1, property 2, and then what this console log does is we can decide which property to print each time. So then this will be console log, and then instead of that it'll be this prop 2. And just to give you an example of how that would work, I could say print last name first, then first name. And then if I hit run, you'll see that it did Tidwell Travis. Pretty cool thing, but essentially what I'm doing here is the way that call works is you pass the arguments as you would normally pass them into the function. The only difference is the first argument is the this pointer you want to use when that method is called. Now apply is a little bit differently, works a little bit different. Instead of actually using these arguments being added to the actual method call, the way apply works is its second argument is an array of arguments. And what it does is it translates this array of arguments to the actual arguments that get passed into the function. So it's like this one at index 0 gets assigned to prop 1, the one at index 1 gets assigned to prop 2. So then if I hit run, you notice I get the same thing, but I could change this to first name, and I could change this to last name, and essentially now it says my first and last name in order at that point. So with that said, there's really 3 methods you need to know. You need to know bind, what it does. It binds the this pointer so that whenever the function is triggered or invoked at a later time, the this pointer is established. There's call, which invokes the method immediately and establishes the this pointer and translates the and directly translates the arguments. And then there's apply, which works almost exactly like call. The only difference is you use array syntax. You typically see apply whenever you're dealing with functions where the arguments are not specified. So you could say call order like this, and you could say, and instead of this it would be arguments. Oh, this needs to be var. And so then this would just be arguments. And so then if I just said call order, first name, last name, the arguments are actually going to be an array, and it all still works because essentially what I'm doing here is I'm passing arguments. Those arguments are passed here as an array, and that array is getting translated into the setName method. So it's a really, really neat capability there. So now that we understand the this pointer in JavaScript, I think the next proper step is to move on to object-oriented JavaScript. And to do that, I think we really need to start with understanding the prototype of JavaScript. And this is another one of those keywords that you see a lot in JavaScript languages that's a little bit obscure as to what the prototype really is. So I'd like to take a few moments to just really kind of dive pretty deep into what that is. The way I like to describe the prototype is that it serves as the blueprint for object instances. So anytime you create, let's say, a new function or a new declaration of a class, that creates a prototype. So just to give you an example, let me just create a new person class. In my person class, I want to be able to pass in the first name, last name, and that's going to assign the first name properties. And the class is actually declared as a function. That's one of the very first things that I'll talk about, is that whenever you're declaring a class, you're essentially creating a function. And you notice that I used a capital P in person. The reason is because this is the class name, and the class serves as the prototype or the blueprint for instances that are created. So it's really important to know the difference between the class and instances. So here I'm creating a class. If I were to create an instance, I would be doing something like this, where it's Travis is equal to new person, and it's Travis Tidwell. So what is essentially happening here is, here I'm creating the class, here I'm creating an instance of that class using the new keyword. Prototype is something that is used and it's attached to the class declaration using the prototype keyword. So I could actually do a console log of person prototype, and this would actually print out the object. It's an empty object right now because there's nothing really attached to the prototype. But the point is that this is a valid object that's attached to any function or class that defines a blueprint for all of the object instances that gets created. So one very common thing that you see people do, and this is just to give you an example, is they, within their actual class declaration, they'll create, let's say, a method, and this method will be called getName. And this method will just return this first name, last name. And when you actually do a console log of this, everything seems to work. In fact, it works great. You're like, okay, I did it right. This is where JavaScript gets you. You know, you do things and it works, and so therefore if it works, you're said, okay, I did that the right way. The problem with this is that every single person we create, so let's just say I create another one called Joe. Every person that I create will essentially get their own instance or their own version of the getName method. And the reason is because when I'm actually creating new, I'm calling this function. This function is called, and this getName method is getting created every single time. This is where prototype comes into play. Prototype allows me to say, okay, I want to create this method on the getName, but I want all of my instances to share the same method. I don't have to redeclare this method every time. So what I would rather do is create a blueprint, and that blueprint includes a method called getName. So to fix this, it's actually fairly simple. All we have to do is we just go person, prototype, and then next to prototype, we can just copy this method right here, and everything else works the same. And now I can delete this, this method. And so essentially what I'm doing here is I'm saying the getName method is part of the prototype, so that whenever I create a new instance, this getName is actually on allowed on that prototype. So the way to think about this is, whenever you create a new instance, so I'm creating a new instance right here called Travis, what the new keyword does is it looks at that prototype and it copies all of the prototype methods, and it then assigns them to the instance variable. So now if I run this, you notice everything is just fine. In fact, Joe, if I do him, you'll notice that he works well as well. So the getName method is actually allowed on the Joe prototype. So this is really important for JavaScript, especially whenever we start talking about inheritance, because inheritance, the way inheritance works is it uses that prototype to extend the blueprint, the original blueprint. So let me just give you an example. We're going to create a new class here, and it's going to be called employee. And the employee works just like a person. The only difference is it has an employee ID. And this employee ID is then going to be used onto the object. Now I have an option here. I can also do this, where I can re-instantiate all of these objects. So this is one way to do it, and this works. The only problem is we're not really using inheritance here. We're just redefining the objects and including employee. What I would rather do is use object-oriented principles to where I get the way person works, and I get all of its prototypes as well. And so the way that you can do that is you can assign the employee prototype. So I can say employee prototype, and what I'm going to do is I'm going to copy the person's prototype and assign it to the employee. And to do that, use object create. And what object create does, it's similar to new. The only difference is that you don't actually have to instantiate the constructor function. So it's not actually going to call the person constructor. It's just quite simply going to create a new object of whatever I pass in. And I am going to copy the person's prototype. So right here, what I have done is I have copied this getName method, and it now belongs to the employee prototype as well. There's one problem here, and the only problem is that whenever we do this, we are essentially overriding another special property in JavaScript called constructor, and that looks a little bit like this, prototype. So as of right now, this right here, this prototype constructor is assigned to the person constructor, because the person constructor is part of that prototype. It's copying it all over. We now have, anytime we do new employee, it's not going to call the employee constructor. This is pretty easily fixable. You just reassign it to the employee method. So here we're saying, okay, reset the employee constructor to the employee. So a lot of times you'll see this being used in object-oriented, but that's essentially what's happening here. You're copying the prototype, resetting the constructor. And then now inside of our employee class, we have the ability to call, using the call method that we just learned, of the person, and then providing our own argument. So I'm going to say person call. I'm going to use this pointer for the employee, and I'm going to do first name, last name, because this accepts first name and last name. So what I've actually done here is I'm actually calling this person with this pointer, and then after here I'm going to say employee ID is equal to employee ID. So now essentially what I've done is I've created a new class. So I could say var Travis new employee, and I could say Travis as well. Let's say I'm number ID 123. And if I did a console log Travis get name, you'll see that this still works. Travis did well. That's great. What if I just do a console log of the Travis? I'm just curious to see if I'll get that employee ID, and sure enough, I do. So I am extending the employee, and I'm also providing the properties from person. Let's say that we want to override the getName method and provide our own the employee attribute. And so you see this a lot within object-oriented. You call the superclass, and the superclass triggers the super method, and from there you can extend your own. Well, you can do that in JavaScript too by just defining that prototype method. So employee prototype get name. And then what I'm going to do, what I'd like to do is just work the same way that this works. The only difference is I want to append or prepend the employee ID next to it. So what I'll do is I'll say return this employee ID plus, I'll do a colon there to kind of separate it. Now I could just copy and paste this if I wanted to. I could do this. That's fine. That's allowed. The other option is that I can get the parent's version of it. So let me just actually assign that to a variable. So we'll say person name equals to the person prototype get name. I have to call it with my this pointer and then assign that to the person name. And then what I'm going to do is I'm going to add that right there. So this is a very, very common pattern you see within object-oriented so that you can call your superclass and make sure that the superclass has their play in your object-oriented code. So now if I did Travis get name, what you'll see is that I have my employee ID, but then also I get my regular ID, which comes from this person get name prototype. So here we essentially have object-oriented JavaScript using the prototype as well as the inheritance and object create. So another thing that happens a lot is you can create what are called module classes, which essentially combine the module pattern with object-oriented programming. And the way that this works is very similar to what we were doing with JavaScript. The only with the module pattern, the only difference is instead of returning a new object instance, we return a class. So the module pattern works by creating an anonymously executing function like this. So let me just say var person. And inside here, I can actually create my var person class and have local variables as well as outside variables. I can have define different interfaces. So I could say person find one. All of these things can be exposed, but I also have the ability to create local things like num persons. Like it would be a really good example. So I can keep track of how many people are being instantiated using a variable that's contained within my anonymously executed function. And then at that point, all I need to do is return person, and that person becomes my class or my public interface class that I use externally. So this is actually a way that you can combine the module pattern with classes to create a very encapsulated module, which is your class, which is another really good pattern to use. So now that you've seen essentially how to build a class, what I'd also like to do is just show you some very common examples of actually applying this type of logic to real-world scenarios where you're using JavaScript to interface with, let's say, the HTML DOM. To do that, within my presentation, I've actually created some helpers that allow you to easily see some fiddles where I actually can create JavaScript buttons using object-oriented. So to make this actually look a little bit easier, what I'm going to do is open up this fiddle. That'll allow you to see how this works, where I'm essentially creating a class, and this class I'm then assigning to a jQuery button. So you'll see how what this does is this actually adds some classes to the buttons and using object-oriented JavaScript here, and I call this a init method. Some more complex examples of this would be, so let's say that I wanted to extend the class. So let me actually open up this fiddle real quick. And the way that this works is I'm essentially using class-based inheritance to create a different kind of button, which would be called the crazy button, where if you hover over it, you basically ignore, like runs away from your cursor, which is, just something kind of fun to play with, to see how you can create business logic around DOM elements pretty easily using inheritance. And so that's another example that you guys should definitely check out. And then last but not least, what I'd like to talk about is using this into a jQuery plugin. And so the way that this works is, let me actually open up this fiddle to just show you. It's essentially the same fiddle, OOF95ER4, and it's version 13. The only difference that I'm doing here is I'm actually extending jQuery. So let me see if I can extend this, make it a little bit bigger, just so you can kind of see what I'm actually writing here. So all I'm doing is I'm taking my class and I'm adding a crazy button, extending the prototype of jQuery. Keep in mind this fn is the jQuery prototype, and so I'm extending it, and then I'm iterating over each one, and then all I have to do at that point is just create a new instance of a class and pass the jQuery this pointer. I've found that this is a very nice pattern to use when creating jQuery plugins, and you can create them so that they work really well. So let me actually just show you how that works. Again, these are JS fiddles. If you want to actually comb and play it, you can fork it if you want to. All of it's provided right here as well. I'll put that on the video as well. And that's pretty much it. I've pretty much covered everything, and I really appreciate your time for listening in, and thank you so much.